Hello everyone and welcome to Hyperlyceum. This video was provided by Ali Shafi and it's narrated by me, Shadia Ayati. In this video, we're going to introduce the COMSOL Multiphysics software. Let's take a quick look at the history of this software. The company that created it was founded by Litmark and Saidi in 1986. In 1998, this software was released to the public under the name FEMLab. The reason for this naming is that the software uses the Finite Element Method to solve equations. We'll see how this method works later, so there's no need to worry about it right now. Just remember that this is a technique used to solve differential equations. In 2005, the software's name was changed to COMSOL Multiphysics, and new versions have been released since then. COMSOL Multiphysics is popular among students and specialists because it allows access to a wide range of differential equations. Mathematical equations govern the physical phenomena that occur all around us. When we want to analyze one of these phenomena numerically, we need to understand the physics and the equations involved, and then solve them. One special feature of this software is that it provides access to many equations. This capability allows students and specialists in various fields to run simulations of the physical phenomena they're studying. Another unique feature of this software is that it allows us to solve all the equations simultaneously. There may be many governing equations for a certain physical phenomenon, and this powerful software allows us to see the effects these equations have on each other. Additionally, we can solve these equations simultaneously. This is why the software is highly useful, powerful, and popular among students and specialists. In this tutorial, we'll follow these steps. First, we'll get introduced to the software environment. Then, we'll explore the equations and physics available in the software. Based on the problems we have and their governing equations, we'll choose the necessary physics. By linking these physics together, we can solve them all simultaneously. Next, we need to create or import geometry required for the simulation. This software allows you to create geometry directly within the interface. If the geometry is complex, you also have the option to import it from another source into the software. The next step involves setting the materials on the geometry that we have created or imported. One crucial aspect of solving a numerical problem is defining the boundary conditions on the geometry. This ensures accurate results when running the simulation and allows you to achieve the desired outcomes. After applying the boundary conditions, the next step is to mesh the geometry. This process prepares the geometry for solving the differential equations. In another tutorial, we'll provide a detailed explanation of the meshing and the solver procedures. Finally, after solving the equations, we obtain and analyze the results. Now, let's explore the software environment to understand its basics and different sections.